So we've got to show that the idea is that we've in the question before we've worked out all these angles here, these individual angles here. Okay, we have to show, but that's for how many sides on that show? Is that a decagon?
Nanogon, I think.
Nanogon, 9 sides. Okay, so
it's a polygon, I think.
Polygon or whatever. It's got a certain number of sides. We need to show a general formula, so no matter how many sides they throw into it, we could figure it out. Does that make sense?
Is that just the n minus?
That's it. So as soon as you see n, it's called a general formula. Okay, a general formula just means that we've got, we could figure out those angles there, no matter how many sides it had, using this formula. Does that make sense?
Yeah.
Okay, and so the way they do it, or the way that to do it, is like for example, this is another general formula, that n minus 2 times 180.
Yeah.
That's a general formula. It allows you to figure out the interior angles for any sided shape. That's a general formula. Make sense?
Yep.
Okay, so we have to do it for this one here. And luckily, they've actually shown us what we've got to get to. We've got to get to that. Okay? So, do you have any ideas for a start?
Nah.
Nah.
Well, it'd be the opposite of what the interior angle would be like. That it'd have to be the interior angle minus the 360.
Very good. So it's actually, yeah, that's exactly right. So it's going to be 360, because there's 360 angles in that point,
Yeah.
minus the interior angle in here. So it's kind of like we know that that point there is going to add 360. If we figure out that point in there, we can then figure out that point on the outside. Okay, which is what you did in the question before, but now we need to just extend it.
Well, the question before it says the edge angles as well.
Yeah, so that's an edge angle. That's an edge angle there. That's an edge angle. All that showed at angles, the edge angles.
How's that right then? Because on the thing it said it was right, but I must have worked out the interior angles then.
Potentially. Is that for the question before?
This one.
This one here. Okay, we'll have a look at that in a second. Okay, just until we do this one here. So, what we're going to do is we're going to say, just based exactly on what you said, to work out the total number of the interior angles, so the total number of degrees in this, for interior angles, we can go 180 times by what? How do you work out an individual, or how do you work out interior angles?
Oh, n minus 2.
N minus 2. Right? And if I expand that out, I'm going to go 180 times n. What's that?
180 n.
180 n. And then I'm going to go 180 times negative 2, which equals... what's 2 times 180?
360.
Yeah, but it's a negative 360 because I'm doing negative 2. So that there is how I work out the total number of interior angles. Okay? But if it was an n-sided shape, we don't know what n is. Okay? I'm now going to work out how I work out the total angles at each vertex. A vertex, by vertex I mean how many, so essentially, how many degrees are at that point, plus 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 that point, that one. Okay?
Yeah.
How many degrees would be there at that point there, Ben?
What do you mean, like at
At
360?
360, right?
Yeah.
So, to work out the total number of degrees at every single point, how would I work it out?
That n minus 2.
You wouldn't have to do n minus 2 in this case. If there's 360 at that point,
Oh, you just find the opposite of that and then times that by 9.
close. Just listen to what I'm asking. So, I need there's 360 degrees at that point, and at that point. How can I work out the total number of angles from each point? So that would be 360.
360 times.
Yeah, that's exactly
9.
right. It's going to be 360. In this case, it would be 9. If it was an n-sided shape, what would it be? 360 times n, right? So I'll just write it. So the total angles... This, by the way, was the total interior angles. That's what I was working out there, right?
Yeah.
Now, the total angles at each vertex, or I'll just write... I'll write vertex. Vertex just means corner. Okay, so at each, that's a vertex there.
Yeah.
Okay, so at each vertex will equal what you just told me. It's 360 times by the number of sides. That's an n. Okay?
Yeah.
Make sense?
Yep.
Now, the total edge angles, so that is all these things here added together,
Yeah.
will simply be that, because it's all the points there, minus the total interior angles.
Yeah, which we
Make
know.
sense?
Yeah, from the other question.
Which we know from the other question. So I'll write that. So we've got total edge angles will equal, and I'm just going to shorten this to TV minus, and I'm going to shorten that to TI, okay?
Yeah.
TI, which in this case will equal, what's TV?
TV is 360 times. Yeah, 360 in.
360 in, and I'm going to minus TI, and so TI is that there. Is that there, okay? So I'm going to go minus bracket 180 minus, in minus 360. Oh, let's do that again. So 180 in minus 360,
Yeah.
right? So that will simplify out to, hopefully, what we want, which is
180 in.
positive 180 in, and then it's negative times a negative, so positive, have I done that wrong?
Or it'd be the 360 we get crossed
Oh,
out.
sorry, there's an
positive.
in, there's an in there. So it's 180 in plus, so 360 in times, negative, sorry, let's do that again. So we've got a negative times 180 in,
Yeah, which.
that would be what, negative 180 in,
Yeah.
and I minus that off that 360 in. So I'm left with positive 180 in,
Okay.
right?
Yeah, kind of. What do you mean? So.
So I'll simplify this, this point here, okay? So I'm going to get rid of these brackets. So negative times 180 is what? Negative times 180 in is?
Negative. What do you mean? 360 in times 180.
No, so I'm just going to expand these brackets.
Oh, I get you. It means 180
Okay,
because
so-
it's 360 minus 180.
Yeah. So I'm just going to get rid of this and just do that again. So it's negative. Remember, it was a 180 in there.
180 in minus
So-
360.
Yeah. So it's negative times that 180 in would be a negative 180 in. And then there was a negative outside the brackets, and we were times in that negative 360. So it becomes positive 360.
Yeah.
All right? Happy with that?
Yep.
So now that there simplifies. Oh my goodness, that's an in as well. Sorry, that's an in.
Yeah.
So that will simplify
To 180 in
180 in.
plus
180
360.
in plus 360. And then I'm just going to go up here because I don't have enough room. That there, what can I factorise out of that there? What's common about them? Because remember, I'm trying to get to that.
So. Oh, they both got 180.
Both got 180 in it.
Oh, so then it's just 180 in plus 2.
180 in plus 2. And that's it there.
So that's what you write.
That's the answer. Yeah. Okay, so it's actually not too bad. You'd have to work out the total interior angles,
Yeah.
and you're going to minus that off the total of all those individual points.
So is that like that with anyone?
Yep.
That's
So
got that
if I had a four-sided shape now, I could go. If I wanted to work out, so here's my four-sided shape. That there.
Yep.
And I'm going to work out this thing here.
Yeah.
That angle plus that angle plus that angle on the outside and plus that angle there.
Minus the
Use the
inside
drawing.
angles.
I don't even need to minus the inside angles.
Just
To
minus
work that out,
360.
I would just go 180 times n plus 2. So 4 plus 2 is
6.
6. So 180 times 6 is 7,
A bit.
is 1080, I think. And so those angles there add up to 1080. Does that make
But
sense?
if we're trying to get to that bit there,
Yeah.
then we'd have to do what we just did before and write out all that 180 and stuff like that.
Yeah, yeah. That's the answer to this one here. I'm just showing that works for
Yeah.
any side shape. Okay?